Welcome back. So today we have started. We have discussed already what is electrolysis plating, how it is carried out, and also we have seen the advantages of electrolysis plating over electroplating, isn't it? So today let us take a few examples of nickel. Electrolysis plating, such as nickel electrolysis plating and copper electrolysis plating, and let's see how these electrolysis platings are carried out. Okay, one by one. To start with nickel electrolysis plating. So this nickel electrolysis plating we're going to use, as you know, there is no anode and cathode. The base metal itself, or the substrate, the base metal is called a substrate. The metal which takes coating or to be coated itself is called a substrate or the base metal. So that is dipped in a solution or the plating bath solution. For that you're supposed to coat nickel, means you're supposed to add a salt of nickel, right? So the plating bath composition contains, so the electrolyte it contains nickel chloride, and it requires the reducing agent. Reducing agent is which produce the electrons to nickel, right? As soon as you have nickel chloride will dissociate to give Ni2 plus and Cl minus. So Ni2 plus requires electrons. From where it requires is reducing agent. Reducing agent undergoes self oxidation to give Ni2 to give electrons. The hypophosphate is used as a reducing agent. Buffer is used a state buffer. Buffer is added in order to maintain constant pH. So pH, since it is a reducing agent is hypophosphate, to pH is around 4 to 5. Complexing agent is sodium succinate. The complexing agent is used in order to prevent the reduction of nickel elsewhere other than this. Okay, reduction should occur only on the surface of metal, not elsewhere. For that sake, you are going to add sodium succinate, the complexing agent. This will form this sodium succinate will attack the nickel ions and form a complex and liberate this only on the surface of the nickel. Okay. Next, temperature is 45 to 360 degree, 45 to 60 degrees Celsius. Cathode, as usual, article to be plated. The reaction. So at anode, what happens? The hypophosphate will dissociate to give you phosphate ion and 2 electrons. These 2 electrons will be accepted by nickel and gets reduced to Ni. So this is the electrolysis plating. This is the object to be plated. This is the electrolyte plating bath solution. The hypophosphate undergoes the oxidation to give electrons. These electrons will be accepted by Ni2+. This Ni2+ will be reduced to form Ni. Ni will be coated on the surface of the substrate. Okay. So applications, it is used as a wear resistance, and other thing is for chromium plating or any plating, we are going to use as an undercoating. Okay, so nickel coating on polymers is used for decorative knob in hi-fi equipment, stops and bottles. Such type of bottles are going to use nickel plating. Okay, this is nickel coated. For refrigerating and washing machines, we're going to do undercoating. So the refrigerators and washing machines will be painted. So if paint goes off and if you touch the refrigerator, you will not get shock because nickel coating is there. Even that nickel coating is gone, and if you touch, what will happen? You get that shock, right? So small plain machineries can be coated using this nickel plating. Okay, electrolysis plating. Next, we have electrolysis plating of copper. Here, this electrolysis plating of copper is having a very vast applications. So what are those applications? Let us see. What are the applications of that? We'll discuss later. So this electrolysis plating, the article to be plated electrolytically, is first degreased. Okay, oil and grease will be removed. It will be cleaned. Next, it will be activated. So how it is activated? By dipping alternately in stannous chloride and palladium chloride. By dipping alternatively in stannous chloride and palladium chloride, it is made active. Then the electrolysis plating is done as follows. The catalytically active metal surface will act as cathode or substrate. For that, you are going to add source of metal. What is the source of metal? Copper sulfate. You require copper, right? As soon as you add copper sulfate, it dissociates to give Cu2 plus and SO4 2 minus ions. So this Cu2 plus ion should require electrons to get reduction. From where you get adding reducing agent. Reducing agent is formaldehyde. So formaldehyde undergoes reduction, undergoes self-oxidation liberating electrons. These electrons will be accepted by Cu2+. We'll see those reactions later. The complexing agent is EDTA. So complexing agent will form a complex with the Cu2+, okay, and it releases the metal ions only on the surface of the metal. Buffer is NaOH, temperature 25 degrees Celsius and pH is around 11. So at anode, what happens? The formaldehyde, in presence of the hydroxyl ion, that is base, it liberates formate ion and two electrons. So these two, that is the anodic reaction. That is, the formaldehyde undergoes oxidation. These two electrons will be accepted by Cu2 plus at cathode and get reduced to Cu. The major application of this copper plating is PCBs, printed circuit board. What is printed circuit board? When you open your television or tape recorder, you can see something green color like this, right? This one. Can you see here? There's a capacitor, right? There is a resistor. So all this is called PCB. This is a motherboard. Okay, this is PCB. You can, this is plastic. This is completely made up of plastic. Printed circuit board. So earlier used to have a huge televisions, huge tape recorders. Now it is reduced the size. Of course, the major contribution is that technology. Other thing is PCBs. Earlier, each and every circuit used to be interconnected. Now everything is merged and it is form a single circuit like this, single plate like this. This is 10 to 12 circuits put together. The circuits you can see here, which is drawn neatly. Can you see? Yes. So through this, and it is used in plating insulators and is also used to make through hole connections. Let us see how this PCB is made. So first we're going to take a plastic metal, okay, and we're going to coat copper plastic material or epoxy material, and going to coat plastic on, copper on either side. So once you coat copper on either side, we're going to print the circuit of using each resistant. What is each resistant? I'll tell you. So I have taken a copper, I have taken this, let us assume this is the plastic, okay. I have printed a circuit on either side using each resistant chemical. Now I'm going to dip it in ammonia. So what will happen? Wherever copper is there, wherever circuit is there, only copper will be present. You can see this written, handwritten thing, that is copper, okay. Everywhere else copper will go up except on this black thing, that is called as its resistant. But dip in ammonia, copper will not be removed, copper will not be etched off, that is called as etch resistant. Removing copper when it is dipped in ammonia is called as etch resistant, okay. So similarly, we're going to take n number of circuits, circuit 1, circuit 2, circuit 3, 4, 5, 6, 7, 8, 9, 10, and place one above the other so that it will not overlap each and every circuit. Then I'm going to drill a hole as shown over here. Drill a hole so that each and every circuit is not disturbed. Drill a hole, you're supposed to take care that other circuits are not disturbed. Later, if you want to connect the first circuit with the last circuit, if you pass current, it will connect. No, there is circuit here, but there is plastic here. There is plastic here. Now, how do you connect? You're going to literally plate copper inside this. So that plating of copper using electroless plating is called as through hole connection. Once you plate copper through that holes, when you connect the first with the fifth, connect. Fifth with the 10th, it will connect. Sixth with the 10th, it will connect. That is called as through hole connections. This entire thing, PCB, is done by that. You can see which circuit is connected by which. The circuit diagram is present over here. By this you can make out. Okay, this is called through hole connection. So PCB is printed circuit board. This is combination of many circuits. You can see very easily, which is drawn over here. Okay, there is a small video over here, so you can see how this PCB is manufactured industrially. Okay, so almost it's a huge video. It takes almost you can just see how PCBs are made. So in India, we have an Austrian company near Nanjangud. While going to from Mysore to Nanjangud, there is an Austrian company where they manufacture PCBs. Okay. If you get a chance to visit, you can visit. So without PCBs, no e-devices will exist. Maybe your laptop, maybe your television, or your mobile, anything. So PCBs plays a very, very important role, and of course, the contribution of chemistry is also there in major extent. Just have a look how it is produced. See, these are the tracks which are produced. Keep waiting through 4 holes. Different types of necklace pattern. This output you can see.